Okay, welcome. This is the first of many of the review videos in my series here for the AP Calc summer assignment. This first video is going to be about part A of the worksheet or of the packet, which is on functions. Part A is really just about the mechanics of functions. As you skim through and look through the problems in this packet, you're going to notice that a lot of the problems have to do with different analytical tricks about functions. Domain, range, are they even, are they odd, what do their graphs look like, etc. This is just really the mechanics of functions that you need for calculus, and by that I really mean function notation and handling that. So I'm going to do a couple problems similar to the ones in this section in your packet, but not the actual problems. The hope is that if you watch these, it'll refresh your memory of anything that you forgot from Algebra 2 and Pre-Calc that you can do to solve these problems. So suppose we've got a function. We're going to define it as f of x equals 6x minus x squared. Remember, the x that's inside this parentheses is kind of your input. The whole f of x ends up being your output. So if I ask you for something like f of 3 minus f of negative 1, I'm asking you to evaluate that function twice. Once at positive 3, once at negative 1, and then compute the difference of the two values. So we can do this off to the side. F of 3 means we're going to do 6 times 3 minus 3 quantity squared. And that's going to be 18 minus 9. So at 3, this function takes on a value of 9. We'll do the same thing with negative 1. Okay, so we can plug in negative 1. Now be careful, there is a reason why I always put parentheses and then square something. You all should know by now in your calculator that parentheses around the negative 1 means something different than without it. Okay, we want to take the value of negative 1 and multiply it by itself, so we need parentheses around that. So 6 times negative 1 is negative 6, minus positive 1 gets you negative 7. Okay, so to actually do the problem, f of 3 is 9, so we'll replace that. F of negative 1 is negative 7, so we'll replace that. I'll put parentheses around it so we know which is the negative and which is the minus. But double negative really means it's like 9 plus 7, so f of 3 minus f of negative 1 is 16 for that function. Okay, but there's some other things that we can do with functions like this. We can also evaluate this function. We'll use the same one at expressions. Okay, here's an expression, and we're going to be doing a lot with this kind of thing at the beginning of the school year. I don't know how much work you did with this kind of beast in pre-calc, but I'm going to tell you right now. You have a different one on your packet, but the one here in this video, this is going to be part of the definition of the derivative. So we're going to do a lot of evaluations like this at the start of the school year next year, so it's important to see how this is done. So the first thing we do is we're going to take the whole binomial x plus 8 and replace it into the x's. So I get 6 times the quantity x plus h minus x plus h quantity squared. And then we're going to subtract from that the actual function, 6x minus x squared. And we're going to put that all over h. Okay, so first thing we do is we distribute the 6. We get 6x plus 6h. And then we subtract from that. Really, I should have brackets around this because I want to do just f of x plus h first, so I'll put brackets around it so we can respect order of operations. We're going to subtract x plus h quantity squared. Okay, you can FOIL that on your own to just verify that I'm doing it right, but I believe I get x squared plus 2hx plus h squared. Okay, so this whole bracket is f of x plus h. We're going to subtract from that 6x and then positive x squared, because I've got a double negative, all over h. We'll simplify a little more. We'll distribute this negative sign in. So I get 6x plus 6h minus x squared minus 2hx plus h squared. Ooh, I'm running out of space. Let me rewrite that a little bit. I'll do it down here. I get 6x plus 6h minus x squared minus 2hx minus h squared minus 6x plus x squared all over h. But look, things clean up nicely. Okay? The x squareds cancel, the 6x's cancel, and all I'm left with is 6h minus 2hx minus h squared over h. And since every term has an h, I can factor it out and reduce, and I just get 6 minus 2x minus h. Okay, I don't want to give away too much of the course, but if you evaluate this expression and you take its limit as h approaches 0, you're going to get the derivative of f of x. More on that in the fall. There is one other thing that we can do with functions, and it's function composition. We can deal with two functions at once. So we're still going to use this f of x. But now I'm going to introduce a new function. I'll put it in a different color. G of x. We'll call that 2x plus 3. And then I can ask you to tell me what is f of g of x. And if you remember, I know we did this in Algebra 2. I'm sure you did it again in pre-calc. Essentially, this is like saying double substitution. We take the 2x plus 3 and we put it in for g of x. So now we're basically finding the value of that function f using 2x plus 3 as our plug-in. Okay? So now we get 6 times 2x plus 3 minus 2x plus 3 quantity squared. We'll distribute the 6, we get 12x plus 18 minus, when we square this, we get 4x squared plus 12x plus 9. At this stage in the game, you should know how to square binomials. It's foiling, okay? Again, if you don't believe me, like in the last example, you can do it off to the side on your own. Distribute that negative sign in. We get 12x plus 18 minus 4x squared minus 12x minus 9. We can combine some things, so the negative 12 and positive 12x disappears. We can add the positive 18 and the negative 9. So we get negative 4x plus 9. That is f of g of x. Okay, and it might be useful for us if we're working with these two functions to have it that way so that we can get values like f of g of 2. We can just plug it into this function as opposed to taking g of 2 and then f of that result. Okay, so this should refresh your memory a little bit about just the mechanics of working with functions, and this should also help you out with the problems in the packet. Thank you for watching.